Okay, so we're going to prove the angle side theorem, which states that if two angles and the non-included side of one triangle are congruent to the corresponding parts of another triangle, then the triangles are congruent. So if we have angle A congruent to angle D, angle B congruent to angle E, and side BC congruent to side EF, then we know these two triangles are congruent. Let's go ahead and start the proof. So we know by the third angle theorem, right? That if angle A is congruent to angle D and angle B is congruent to angle E, this implies that angle C is congruent to angle F, right? So we know that these two are congruent by the third angle theorem, which was discussed in a previous video. So remember, if you have two angles congruent to two angles, right, in a different triangle, then the third angles must be congruent. All right, so now we have angle, side, angle, right? Angle, side, angle congruency postulate. So we can use that in order to show these two triangles are congruent. Let's go ahead and go down a bit. So we have angle B congruent to angle E. We have BC, side BC, congruent to side EF. And we have angle C congruent to angle F. So, by the angle side angle congruency postulate, we know that triangle ABC is congruent to triangle DEF, which is what we set out to do, right? So remember, let's go back up here. Let's get rid of these right here. So remember, for the future, let me go back one. So for the future, if you have an angle congruent to an angle, angle congruent to an angle, and side congruent to side, right? Then you know the two triangles are congruent by the angle side theorem.